Hi there, kids. I know that for most of us in regular school that this is usually Module 6 later lessons is the time when you get ready for state testing and for year-end assessments. And so I am going to skip a couple lessons. I'll do videos later on those because it's not that they're not important. Everything in here is important. It's just that some things are more important than others, and so I will get back to those later. But I want you to see that when using a graph and plotting points, that there is a reason for understanding how to go forward on the x-axis and move up on the y-axis. So I thought, what better way to learn how to use these properly than to do some word problems with them. So in lesson 19, we get to actually apply our graphing skills. So the objective here is to plot data on line graphs and analyze trends. Now, a trend you probably are familiar with, like who's popular on YouTube, or, just different trends like what type of pants you might want to wear or how short they should be. And so, oh my God, that totally reminds me. I had gone down to LA with my daughter because we were checking out her apartment, and so we ran into these people. So who are these people? They were sitting next to us at dinner in Westwood, and I was like, I don't know who these people are. Isn't that funny? And then my daughter and her friend, they're like, oh my gosh, these guys are YouTubers, TikTokers. They're TikTokers. Anyway, so we sat next to them. They were pretty funny. But trends, that's a trend. TikTok is a trend. Certain people who are like a big deal, that can be very trendy and fun. And so anyway, a trend is something that happens and is very popular for a little while. So a trend is something that is popular for a while. So we're going to be looking at trends. What is a trend on a graph? It's not quite as fun as a trend on TikTok. Anyway, so let's take a look at this rainfall accumulation chart from this particular date, March 4th, 2013. And you have to look, what are we counting by? So this x-axis is showing us time. Okay, it's showing us time is passing. Typically, if you have time, it's going to go on the bottom because time is always marching forward like so. Now, what you're comparing it to here, rainfall in inches, that would increase generally because rain can only fall and accumulate. We're not counting evaporation, so nothing's going to go down. It's only going to go up. Okay. So let's take a look. How many inches? Let's go back up here. The line graph below tracks the rain accumulation. Big word. That means it's like you're collecting it. Measured every half hour during a rainstorm. These are the half-hour increments. Notice that's where the points are on the half-hour increments here. Okay, that's what they mean by every half hour. That's where the points are. During a rainstorm that began at 2 p.m., started at 2 p.m., and ended at 7, that's when we have our last amount of data. Use the information in the graph to answer the questions that follow. So here's your information in the graph. Let's read. How many inches of rain fell during this whole 5-hour period? So look at what your end point is, okay? And this here is 0, of course, because that's the origin point. So we're always starting at, well, not always, but in this graph, we're starting at 0. This is 1 inch. This is 2 inches. So where are we on this graph? Go up here. And what are we counting by? If I have blank, blank, blank 1, blank, blank, blank 2, then you can see that we're counting by quarter inches, and you can label it as such. Okay, and so if I am at 2 right here, and you can even make a little notation, so on this side of the graph, when you're far away from the y-axis, you can refer to what you think your point should be. That can be helpful too. So if I am 1 unit away from 2, and I'm counting by quarter inches, then it would be 2.25, okay? So how many inches of rain fell during this whole 5-hour period? 2.25 inches of rain fell during the storm, or during this period. Okay, next one. During which one half-hour period did ½ inch of rain fall? Now, I need to know how to show a ½ inch. So how can I see a ½ inch? A ½ inch would be 1, 2 units. So which half-hour period will I have an increase of 2 lines? Okay, so what is a half-hour period? A half-hour period is going to be 1, 2 going across. So now I need a change of 2 across and 2 up. And I look at this to find between the points, where does it go 2 across and 2 up at the same time? And right here at the beginning, it goes 2 across and 2 up on this graph. That means 30 minutes of time passed and a ½ inch of rain fell. So this section here shows the change. Half hour, ½ inch of rain. Okay, what is the time period? 2:30 to 3. A ½ inch of rain fell. Okay, 2:30 to 3, a ½ inch of rain fell. How do I know? Okay, I know because the points moved 2 units up, 2 units up, and 2 units over. Okay, so that's the next one. Let's do number C. Letter C. During which half-hour period, again, I need a 2-unit skip, did rain fall most rapidly? What would rapid rainfall look like? That would really make it shoot up the graph. So I need a skip of 2 units going this way, because that's a ½ hour. Do I have a steep increase? And you might jump out at you right here. This is a steep increase right here. Okay, so this is a ½ hour between 4:30 and 5. Okay, and so we need which ½ hour did the rain fall most rapidly, and how do I know? I would say between 4:30 and 5 o'clock, the steep line increase shows me an increase in inches. Okay, so it's this steep increase. That means lots of water is falling. In fact, if you count it by quarter inch, it's going to be a quarter inch, a ½ inch, 3/4 of an inch fell in 30 minutes. That's a lot. We're not used to that in California. Okay, why do you think the line is horizontal? Between horizontal, remember, horizon, sunset, sunrise, flat, between 3:30 and 4:30 p.m. So what's happening here? If there's no increase, and there's not going to be a decrease, okay? If there's no increase, then that means there is no rainfall, or no rain fell in that time. Okay, and basically, look at the title. There's no accumulation. No accumulation. Okay? Sorry, you guys can't see that. Okay, now for E, for every inch of rain that fell here in this town, a nearby community in the mountains received 1.5 feet of snow. How many inches of snow fell in the mountain community between, here's our time frame, 5 and 7? So we're going to look from here to here. I need to know how many inches of rain fell. Okay, so go up here on the chart and see where we are. Back trace, not with your pencil because you don't want to put lines all over the place. So we had 1.75 at the beginning, and then all the way up to here. Remember, this is the 2.25, which is the total, to 2.25. Basically, it went up from 1.75 to 2.25. What's the difference? Okay, so what's the difference? The difference is going to be how many inches fell. So between 1.75 and 2.25, I go up a quarter and then up another quarter. So if I have 1/2 inch rainfall, okay, 1/2 inch of rain fell, what does that translate to in snowfall? Okay, so let's go back down here. We have 1/2 inch of rain. 1/2 inch rain fell. So let's go to our equivalent. For every inch of rain, they get 1.5 feet of snow. Let's make 1.5 feet into inches, okay? Because 1.5 feet is not the right unit. I can't compare if I'm using 1/2 inch. So 1.5 feet in inches would be 12 inches plus 6 inches. That makes 18 inches of snow. But I need half of that. And what is half of 18? 9 inches of snow. And that is number 1. So that whole thing, that's what graphing is all about. This is like the end goal. So you're presented with a graph. You should know how to use this bottom and the side axis to compare your points on the graph and then find the difference between them and use them for practical purposes. Let's do it again. That was so much fun. Okay, Mr. Boyd checks the gauge on his home's fuel tank on the first day of every month. The line graph to the right was created using the data he collected. So this is the Boyd's monthly fuel usage. Now usage, if you use something, it's kind of like eating it or making it go away. Okay, so let's look at our graph. We have the months of the year, which are represented by just the letter: January, February, March, April, May, June, July, August, September, October, November, December. Yes, it spells Jason right there. I noticed that a long time ago. And then on the side, you have the fuel gauge reading. Now, notice we have no numbers, but we have empty, half, full. Okay, that's going to be important later. We'll have to figure it out. So he checks the fuel gauge, and these points for each month's reading it's going to give us information about how much fuel is in the tank. So let's find out what's going on here. According to the graph, during which month or months does the amount of fuel decrease most rapidly? So what would a rapid decrease look like? So a rapid decrease would go from full toward empty, so going downward the fastest. So if I look at, we don't have any real statistics here. We're just saying which lines go down. Well, this line goes down from here to here. I would say that is the most rapid because in 1 month it went down 3 units. Okay. In this next month it went down 2 units. Then it starts to taper off because it only goes down like 1 little unit and then kind of not even quite that. And then it goes way up. We'll talk about that in a minute. And then it's very, It's fine. And it never gets past 1 unit. So the month or months when it decreases most rapidly would definitely be this one and this one. Okay, so we can say January and February. Doesn't ask us to explain, but you should know that it's because the downward slant is telling you that. The Boyds took a month-long vacation. Wow, must be nice. During which month did this most likely occur? Now you have to explain. So if they take a vacation, what's happening with their fuel usage? It wouldn't go down. And it wouldn't go up either because nobody's coming by the house. So you would expect it to stay the same. Now, if we're talking about full to empty, that means it's going to stay the same. At what point is the fuel staying the same? Right here. So go down to this, and you would say, according to this, that month is July, right before August. So it looks like July, there was no change in the tank. Okay, it didn't go down, it didn't go up, there's just nothing. And there's very little usage for August as well. So, but it just says 1 month, so we're going to go with July. Mr. Boyd's fuel company filled his tank once this year. I wonder when that happened. They filled it, they made it get up to full. During which month did this most likely occur? Explain how you know. So when you see in 1 month's time this enormous increase going from not quite empty, so say half, but it goes up and it's almost full, what month is this? Okay, January, February, March, April, May. In May, it was filled because there is a sharp increase in the fuel in the tank. Okay, so there you go, sharp increase. All right, and the next one, the Boyd family's fuel tank holds, here it comes, this is the important stuff, 284 gallons of fuel when full. Let's write that down. 284 gallons when full. How many gallons of fuel did the Boyds use in February? Uh-oh, I have to figure out what this point is here and this point is here. Okay, right here and here. Because what I need to know is how much fuel this is between here and here. Okay, so let's take a look at our sections on the graph. I want to break this into units. How many units are in this 284? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 sections in my 284 units. So one way to do this is to take the 16 sections and you could divide it into the 284. Okay, and you could figure out the amount of each and then you could multiply it by 2, or you could do 2 of that. But let's find out what each section is worth in case there are any other questions that we have to do per section. Okay, so 16 into 284, 16 times 2 would be 32, so we're going to have 1. Make sure you guys can see. It looks a little blurry. There it goes. Minus, we got 12, bring down the 4. And then that is pretty close, so I'm going to guess about a 7, because 7 8, 9, 10, 11 if I multiply by 4. So 7 times 6 is 42, and there's the 4, and then that would be 11. And then we have a difference of 12 again, and we don't want that. And so then we can put the 12 out of 16, which really makes, if I divide both by 3, I get 3/4. So 17 and 3/4 would be the amount for each section. Okay, and then you can count by that if you wish to, but we don't really have to at this point, but you could. So then we need to multiply by 2 because we need to know what these two sections are. So 17 and 3/4 times 2. And because this is a mixed number, you can either separate and do 17 times 2 and then 3/4 times 2, or you can wrap this up into an improper fraction. And because it's such a big one, I'm going to separate it out. 17 times 2 plus 3/4 times 2, and look, I can cross cancel. And that gives me 34 plus 3/2 or 1 1/2. 35 1/2. And that is the gallons in the two sections for February. Boop, boop, add that onto my label. So they used 35 1/2 gallons in February. So once you know the amount of one, you can know the amount of any, okay? And then for the last one, Mr. Boyd pays $3.54 per gallon of fuel. What is the cost of the fuel used in February and March? So now I need to take a look at what March is. If February has 2 and March has 1 unit, then what's half of the 35 1/2? I go back to the 1. So I'm going to take the 35 1/2, or you can do 17 and 3/4 times 3. That would work as well, okay, because we already know what 1 is. So 17 times 3 plus 3/4 times 3. And let's do 7 is 21, 351. And then 9/4 is going to be 2 1/4. So 51 plus 2 1/4 equals 53 1/4. So that's how much fuel was used in those 2 months, but now I need to multiply that. Now, how do I multiply when I have 1/4? Remember that fractions can equal decimals. And so if I want to change it to decimals with hundredths, like tenths, hundredths, how do I do that? So you multiply by a scale factor. Remember how to do that? Scale factor. And so then I would get 25 hundredths. So it would be 53, 25 times 354. Sorry, it's like all smashed in here. Okay, and then let's start multiplying. It's a 3-digit multiplication, so I'm going to have 3 partial products. I'm going to have to write small. 5 times 4 is 20. 8 plus 2 is 10. 12, 13, and 21. Your first partial product, 21300. Hold this spot with the 0, multiply. 25, the 2 is already there. 10, 12, 1's already there. 15, 16, 1's already there. 25, 26. Second partial product, all the way across, 266250. Third partial product, hold this spot with a 0, done with the 1's. Hold this spot with a 0, done with the 10's. Hold this, go to the next one, sorry, it's habit. 3 times 5 is 15, carry the 1. 3 times 2 is 6 plus 1 is 7, no carrying. 3 times 3 is 9. 3 times 5 is 15. Last partial product, 1, 5, 9, 7, 5, 0, 0. And then carry it down, and look, I'm all the way into my label, and I'm going to move it up for you. 0 for this column and 5 for this column, and then 8, 9, 10, and 13, 14, 15, and then 10, 16, 17, 18, 5, 6, 7, 8. Don't forget your decimal points. So multiplying with decimals means 1, 2, 3, 4. 1, 2, 3, 4. Place the decimal, and now you have an actual money value. Now, what do you do with this when it goes past the pennies? We only have dimes and pennies in the United States, so you just round it. I would say they spent, or what's the cost? $188.51 for fuel. Okay, and that is the last one. So click subscribe, come back again, and we'll do more fun math. Bye.